Okay, question 3, the projectiles question. So this is like the monkey and the hunter that we've looked at in lessons. The gun fires the bullet at the same time as the electromagnet releases the apple. The apple falls vertically. The bullet moves horizontally and vertically, but what happens is that the bullet manages to hit the apple. And the reason for that is because you have to look at the two components of the motion for this projectile, for the bullet. You have to look at the vertical component of the speed and the horizontal component of the speed completely separately. The horizontal speed stays the same. The vertical speed changes. It's accelerated due to gravity. So what this is asking for here, describe and explain the motion. This is asking for you to separate those two things out, right? The pellet moves horizontally at constant velocity. So wherever it is, wherever the bullet is, the horizontal component of its speed is the same. But vertically, the speed's increasing. It's accelerating due to gravity. Okay, so horizontally is constant velocity. Vertically, it accelerates due to gravity. Okay? Right, now if the distance d is increased and the experiment is repeated, one difference and one similarity. So the bullet will still hit the apple, but the apple will have fallen further, or the apple will fall, it'll be falling for a greater time. So apple will still be hit, but it will fall further before it's hit. Okay, right, now this bit, this next part of the question is, this is completely different now. This has nothing to do with the apple. Now you've got, let's scroll this up a little bit, there you go. Now you've got somebody skimming a stone, and you've got this, it's a projectile in this parabolic path. We're only interested in the first part. Okay, a big difference now with this to other questions that we've done is that normally you're given the velocity, you're told the value of that velocity and the angle that it's at, and then you resolve it into the two components. But here we don't know the overall velocity. I'm going to change that. I'm going to call that big U, so it doesn't confuse us further down the question. Okay, and we do the exact same thing as we've done. I'm going to split this up into two parts, horizontal and vertical motion, like we've done in class. So let's see what we know. I'll go back to this in a moment. Horizontally, we know the total distance travelled. So remember on this, we use speed equals distance divided by time because there's no acceleration. So horizontally, we know it travels 1.2 meters, and the time for the whole of that A to B is 0.4 seconds. Vertically, well, the best way to approach this is to just look at the first half of the parabola. And here, because of the acceleration due to gravity, we use the Silva equations. So A is minus 9.81 meters per second squared. At the top of that path, for a split second, the velocity v is going to be 0, and little u, we're going to call u the vertical component initially. We don't know at this point. The height is what we're going to be asked to find, I imagine, and the time, well, if it takes 0.40 seconds to do the whole of that, the time for the first half of the parabola is just 0.20. Okay? Right, let's have a look at this question then. Calculate the horizontal component of the velocity u, given that the time taken is 0.4. So the horizontal component of the velocity, that's the speed here, which is distance divided by time. And that is 3 meters per second. Okay, so that's the horizontal component here, 3 meters per second. We would call that big U cos 35 when we resolve the velocity vector, but U cos 35, we've just worked it out, is 3 meters per second. This bit here, the vertical component of the velocity, is big U sine 35. And that's what we don't yet know, but we can work that out. All right, we need to find the height h. Let's work out u. Using v equals u plus at. So you select the equation that doesn't have x in it, and it's v equals u plus at. So 0 equals u plus, and this is minus 9.81 times the time, which is 0.20. So u equals 9.81 times 0.20 is 1.96 meters per second. That bracket is a minus, so we take it over to the side, it becomes a plus. So if we now know that u is 1.96, we can work out x using x equals ut plus a half a t squared, and that is 1.96 times 0.2 plus a half times minus 9.81 times t squared. So the first bracket is 0.92, and the second bracket is going to be a minus, and that is 0.5 times 9.81 times 0.2 squared. That is minus 1.96. So 3.92 minus 1.96 equals 1.96 meters. And that's the height. And does that look like a sensible number? Yeah, it does, doesn't it? Okay. Right, calculate the total energy of the stone at height h. Okay, total energy of the stone. So this is the clue here, and this is where, well, I actually went wrong to start with. I just looked at the gravitational potential energy. So at that height, it has a gravitational potential energy of, well, it's mgh, so it's 0.10 times 9.81 times, what was the height? It's height h, 1.96. 0.10 times 9.81 times 1.96, and that is 0.19, and the kinetic energy equation is half mv squared equals 0.5 times 0.1 times the velocity, which is the speed we've calculated, 3, and that is 0.5 times 0.1 times 3 squared, so that is 0.45 joules. Okay, total energy is 0.19 plus 0.45, which is 0.64 joules. Okay. Finally, the thrower believes that the stone loses 20% of its energy every time it impacts with the water. Investigate whether or not this is true for the impact at B, given the fact that the stone's velocity just before impacting the water is 3.3. So at this point here, it has some kinetic energy and some gravitational potential energy. But when it hits the water, or just before it hits the water actually, all that is kinetic energy. So we can say that that 0.64 is converted to kinetic energy. But, oh, right, what about this 20% of energy lost? So what's 80% of that? 80% of 0.64, that's 0.64 times 0.80, that's how you do that. How much has it lost? 0.64 times 0.80. So that would just be 0.51 joules. So that's 80%. If the thrower believes it's lost 20%, 80% of 0.64 is 0.51. And if that is the case, is the velocity 3.3. So if this is all kinetic energy, that means half mv squared is 0.51. And let's work out v, see if we can get 3.3. V squared is 2 times 0.51 divided by the mass, which is 0.10. And v actually is the square root of all that. So let's see what we get. 2 times 0.51 divided by 0.10, and then find the square root of that. My answer is 3.2. So yes, this is true.